Today, it's a revival. That's right, we're going to bring a 50-year-old rusting drill press back from the dead. This story is insane. No, really, literally insane, crazy. More on that in a second, though. So, today we're going to revive this Manhattan Supply Company floor standing drill press. I bought it at an auction for $60, sight unseen, expecting it to be a non-functioning piece of equipment, and sure enough, it was. Stone dead. So, we're not only going to get it up and running, we're going to make it look, well, verging on brand new. And we'll do it over a weekend. More or less. So, like I said, the story here is insane. Actually, the story isn't insane. I think the insane part of this story is me. Now, follow along with me, and you'll not only learn a little bit about my fragile mental state, but you'll also learn in detail how a drill press works. All right, let's get cranking. Okay, so I'm going to start by tearing this old lady down to the screws, but while I do that, a little background on this particular drill press. Now, like I said, I bought this from an online auction that specializes in industrial gear. It's an old machine shop. It's being liquidated. The owner was retiring, and they were getting rid of every single, drill press, table saw, mill, chairs, tables, every scrap of stuff in the whole place. Now, about 3 years ago, I moved from a really tiny shop where space was completely at a premium to this great big old place right here. Now, I'd always had a benchtop drill press to save space, but I've been meaning to get a floor standing drill for ages, so now is the time. They were selling a whole bunch of these drill presses. Some of them were super nice, some of them super old and beat up. So I figured, if I could steal one, that would be cool. So I put in a bid early in the auction for this real beat up old drill press. And, my thinking was, if I couldn't get a nice one later, if it was just too expensive, I'd have something that I could refurb. Well, as it turned out, I ended up getting two drill presses. One fully functioning plug and play Rikon that's back behind me, and then the one that we're fixing up today. Hey, look, I spent $60 on it. I could have just junked the thing or resold it or something, look at it as kind of cost of doing business. But, I figured I'd see what could be done with it. So first thing I did, I just pulled the switch, stuck a screwdriver across the terminals to see, what would happen. Lo and behold, motor turns. So I knew that I could get this thing going, worst case scenario, just spinning if I just replace the switch. I figured, okay, I'll replace the switch, I'll spiff up a couple of things and be done with it. It'll be kind of a spare. I can stick it off in the corner of the shop, not really spend much time on it. Well, here's where the mental illness kicks in. My obsessiveness just took over, and the next thing you know, the entire drill press is spread all over my shop, and I'm cleaning gears with a toothbrush, and, what can I say? It just kind of happened. I didn't set out to do that, but that's where I ended up. So here's the serial number plate. Manhattan Supply Company is now known as MSC, which is, one of the biggest suppliers of industrial stuff on the planet. They sell everything from drill bits to motors, hydraulic hoses, actuators, pumps, just all that kind of stuff. So anyway, they changed their name from Manhattan Supply Company to MSC somewhere around 1970. So this drill's got to be around 50 years old, plus or minus a little. I don't know when they actually got rid of the Manhattan Supply Company brand, in terms of the actual products that they produce. But I know it didn't last too long. Eventually, MSC phased out the Manhattan Supply Company brand. And this particular machine was made in Taiwan, and you can still buy machines that are virtually identical, probably made in the same factory. Anyway, this machine shop that I bought this from manufactured screws on these old machines that used constant flow oil coolant. and I have never seen so much oil in one place in my life. So when I went and picked up this drill, I mean, every surface of the shop was just covered with oil, and so like everything else in that shop, this drill was coated with oil. Now probably polymerized, so if you wanted to paint them, you needed to strip every painted surface completely. Hey guys, let me jump in here to mention that I'm only able to do these because of your support on Patreon. If you like what I'm doing here, if you see value in the years and years of gear reviews and tutorials that I've done here on YouTube, I'd earnestly ask you to pitch in and help out. In return, you'll have access to years and years of plans for knife builds and cool tools that I've made during all the time that I've been on YouTube. Sincere thanks to all the guys who are helping out the channel. All right, back to it. So, I did this in 2 stages. Dredging them in mineral spirits and wire brushing off most of the old oil. And then using an abrasive blasting cabinet to remove all the remaining paint and crud and get down to bare metal. So let me pause here to talk about why I actually did this project. Like I said, I kind of slid into it, but you know, first off, I did not do this for the money. I can damn sure tell you that. Like I said, I paid $60 for the machine. Now, you can probably buy a pretty comparable machine, brand new from Grizzly or Jet or Delta or maybe even MSC, somewhere in the $700 to $1,000 range. So, you know, if I invested like $500 in parts and labor in the machine, I'd more or less break even. But fact is, I know diddly squat about how drill presses work, and I just was like, well, hey, if I take this thing apart, really, you know, look at every single piece, fix it up, put it back together, hey, I'm going to learn a ton of stuff about how drill presses work. And that, I got to say, I accomplished 100%. So before we get back to fixing up the press, let's break down how it works. So the press consists of a head, a table, a column, and a base. The head is cast iron and contains the guts in the machine, and then on the top is a 3-pulley system. In this particular case, some drill presses only have 2 pulleys, which gives it 16 possible speeds by moving these belts around. Now, each pulley, interestingly enough, is mounted totally differently. The first one is on the motor. Now, this other pulley that drives the spindle has a retaining bolt on top, big old huge one, and it mounts on a tapered shaft. I used a gear puller to get it off. There's a spline shaft that spins around and rides up and down. So you have 2 degrees of freedom in this thing, one for spinning it and one for feeding the drill down into the work. And the third pulley, the one in the middle, supposedly floats. I had to look this up on the interwebs, but it was actually kind of frozen in there. So I had to flip the whole head over, take a punch, and beat the thing free. Now the spindle and feed handle come out like this. You take this bolt off, there's a little spring assembly that gives spring tension to the feed arm. And then inside you have the spindle riding inside the frame with a rack on it that engages the teeth of the feed pinion, which is attached to the handle. So the gear turns, drill bit goes up and down, voila, drill press. Now, moving back to the rear of the head, you have a little handle with two tensioner shafts that move the motor in and out so you can loosen the tension on the pulleys and change speeds. There's a sort of cam bolted to the handle here that rides in a slot on one of these two rods. You loosen these two screws on the side of the head, which frees the two rods to move back and forth. Then you tension or detension the pulleys by moving the rods using that handle, which in turn pushes the motor and its pulley forward or backward. It's really a simple, elegant, robust piece of engineering. Now, returning to the pulleys, there's a bearing up in the pulley mount for the spindle that I'll leave as is, and then another bearing here in the spindle, right above the drill chuck. Now, I'm guessing that this machine was rebuilt somewhere along the way because these bearings really seem very sound. I mean, there's no obvious wobble, play, nothing. I mean, they just seem good. We'll verify that later, but in the meantime, I'm not pulling any of that apart. The table rides up and down on this long rack that sort of floats on the side of the column. There's a retaining ring at the top and a little groove on the column base that this rack rides in so it can move freely around the column. Wow, look at all that crud. I mean, it's just amazing how much gunk is in there. So like I said earlier, once I'd taken it all apart, it's into the mineral spirits. Then into the blast cabinet. Here's a look at how the various parts came out. Now, I can tell you as a knife maker who's been dealing with fresh steel for a quarter century that bare, freshly exposed cast iron and carbon steel will rust if you even look at them funny. So, I want to get on with the painting as fast as possible. Basically, as soon as I got them out of the blast cabinet, I'd paint them. It's just rattle can enamel paint from Home Depot. You can tell I never worked in an auto body shop, but everything's coming out pretty nice. I painted up the pulley cover, the table mounting arm, and the cast iron base. I wanted to pull the column off the cast base, but a half century of rust had other plans for me. I mean, I tried, but I really didn't want to crack this cast iron, so ultimately I just let it be. Now I'll clean the old grease off most of the moving parts, including the spindle bearings, the feed gear, the gearing inside the table assembly, all that stuff. Just years of nasty, caked on grease, chips, dirt, crud. And I'll grease them up later when I'm ready to assemble everything. Okay, now let's take this scarred up old table over here. I'm using my Haas here like a manual mill, only because it has the biggest work envelope of any mill in my shop. Using a 2.5-inch shell mill, I'll just deck off the top, removing about 15 thou of cast iron. Sweet. Now it's dead flat with most of the nicks taken out. Okay, now here's where the sickness really took hold. I could have just let the column be. It's a little cruddy, a little rusty, but there's nothing wrong with it. Instead, I did this. Yeah, I don't even know what to say. If I had a lathe with a 5-foot bed, I could have done this a lot easier, but I don't, so I did this insane thing here. Surface conditioning belt, basically Scotch-Brite, and I just moved the thing side to side, rotating it by hand until it was pretty much cleaned up. I mean, what can I say? It worked. I'm not trying to make it 100% perfect here, because that would actually require removing a fair amount of material and weakening the column and making the... Anyway, basically just trying to get the surface crud and rust off. Now, there's one last thing to mention before assembly. I did not take the chuck off the spindle. There are actually two ways you can do that. The chuck itself mounts on what's known as a Jacob's taper, which sticks down into the chuck. So you can pop it out of there. In this case, I measured the top of the chuck at 811 thou, which you can look up on charts on the interwebs, and you'll find that that is a Jacob's number 3 taper. Also, you can knock the chuck off from up here inside the spindle, where there's a Morse taper inside the spindle. To do that, you just stick a little wedge in there and whack it out, and the Morse taper part will pop out. Either way works. Like I said, I'll test out the chuck once everything's working. Either way, no point buying a new chuck till I test it and see how this one's holding up. So, now ready to reassemble. First, the column and base. Then the table and associated stuff like the little retaining ring at the top. Took a couple tries actually to figure out the correct order of operations. Now, of course, I've already at this point blown all the stray abrasives out from the table height mechanism and re-greased the rack, pinion, and the worm gear that drives all that stuff. Now, the rack that runs up and down the column was warped and the end was snapped off. So before assembly, I straightened it, and so it works smoothly, but I may want to replace it later. Seems like it works okay, though. Next, the head. In real life, I'd probably assemble the whole head on the bench and then stick it on there in complete form, but that's less fun to film, so I'll mount the head, then reassemble on my tiptoes or balanced up on a chair. Tension adjustment assembly. Lamp. The spindle, the feed arm, the spring that tensions the feed arm. Pulleys and pulley assembly. Motor mount and motor. Table and all the little tighteners and other goodies that go with it. Switches. Now I'll be putting in a new switch, so I temporarily wired the old lamp switch to the motor because that switch was still working. Makes no difference, they're basically the same kind of switch. So now that it's all assembled, I'll test everything out. Alright, so that looks pretty cool. So next I'll test everything out. Using a dial test indicator, I'll test what's known as run out, or more formally TIR, or total indicated run out. That's basically just how far out of perfect nominal concentricity the drill runs. So first I'll measure this on an actual tool in the chuck, What I found there is about 7th thou of run out. It's a little hard to tell because the thing vibrates. Now, a brand new Jacobs chuck is typically rated at about 4th thou. So this is running at just barely worse than factory. So I'm not unhappy with this. Run out on the spindle itself is under 2 thou. So that confirms what I thought earlier, which is that these bearings are really in pretty darn good shape for a half-century old tool. And with that, I am officially done. This is a working drill. I'll be putting on a different switch later and doing a couple other little minor things, but basically we've got a functioning drill. So here we go, glamour shots of what has a passing resemblance anyway to a brand new drill. I gotta say, I am pretty damn happy with how this came out. So let me give you a rundown of the costs. I drove an hour and a half to the other side of Atlanta. I loaded it on my truck, and I got stuck in typical Atlanta Friday traffic driving home. Took me 2 hours to drive home, so that's 5 hours just to get the thing. Started working at 9 o'clock on Saturday morning. Watched a little football during the day, but I worked until 10:30 that night. Next day, Sunday, got up, started working about 9, a little family time sprinkled in there, but again, knocked off probably 9:30 that night. Spent a few hours on Monday, and then I was done. So all told, maybe 30 hours in the course of sort of a long weekend. So, if my time and the overhead of this shop and, my CNC machine, all this junk is worth, let's just pick a number out of the air, $100 an hour, then I got $3,000 of labor and overhead invested in that machine. Hard costs, rattle can paint, some screws and stuff like that, a couple cans of mineral spirits, and 2 switches. So total $75 or so hard cost. So this is either a $135 project, $60 plus the money I spent on paint and stuff, or it's a $3,100 project. So if I choose to look at this as a hobby project, I basically stole a brand new drill press. If I look at this as a professional, which I am, then what economists would call the opportunity cost that I could have put of all this work into something else, this is an act of insanity. Now, I tend to take the latter view of this case, but anyway, I walk away with a pretty nice drill press and a lot more knowledge about how drill presses actually work. So, am I completely crazy, or was this sort of a little mad genius exercise? You be the judge. All right, guys, thanks for watching, and see you soon. Thanks for watching, guys. If you like what we're doing here, please subscribe and make sure that you click on that bell so you get notified of all the latest videos. Want to buy a knife from me? Check out my modern blades at tacticsarmory.com. Digging the channel? You can support our video making efforts on Patreon. I've been banging away on these videos for like 10 years, so I hope you'll show some love for all that hard work. Link in the cards and descriptions. Finally, if you're interested in making Japanese swords, check out my full line of Japanese sword videos where I show how to forge Japanese swords as well as how to polish them and how to make fittings, handles, and scabbards. WalterSorrellsBlades.com.